So in the last example, in example number 3, we're going to use all the skills that we've done up to this point. Okay, so in our situation, it says that the world population was 4.5 billion people in 1980 and has increased at a rate of 2% per year since then. Okay, and so part A says, write an equation for this exponential relationship in the form of y equals a, which is the starting value, times b, the rate of growth or decay, to the exponent x, or how many ever many time units have gone by in the meantime. So y, that's our unknown value. That's what we're trying to figure out. The a, that's our initial value. And our initial value is right here, 4.5 billion people, okay, in 1980. That's when that value was initially taken. Okay, it says that it increased at a rate of 2% per year. And so what we need to do is we've got to figure out that b value. So first thing, anytime that you see a percentage, okay, you have to convert the percentage into a decimal. So 2% is like saying is equal to 2 over 100. And that is the same as 0.02. Okay? So if we want to figure out what the b value is, again, we know that it's going to be increasing because it tells us that it's an increasing value. Then we know that the b value is going to be 1 plus the increase rate. So in this case, 0.02, okay, which is equal to 1.02 if I simplify it. Okay, and that's based on our original summary here. If we look back the first couple of pages here, it says when we have a growth is the b value is going to be 1 plus the rate of growth. Okay, in this case, our rate of growth is 2%, so 1 plus 2% will give us our final value. Okay, so in this case, our equation is actually y is equal to 4.5 times 1.02 to the exponent x, where x is the number of years that have gone by since 1980, or since the initial value. Okay, so that's going to be our formula. So we want to then figure out here in part B, it says what was the population in 1995? Okay, well, our initial population was rated from 1980. So 1995 minus 1980 will tell me the number of years that have gone by since the initial value was calculated. So 15. So what's the population 15 years after? Okay, well, what that means is that the x value is actually 15 years. Okay, so that's the time interval that has gone by. So in our formula, we've got y is equal to 4.5 times 1.02 to the exponent 15 now. Okay, so what I'm going to do is I'm going to calculate this. And again, bear in mind that when you're calculating, you have to do the power first and then multiply it by the a value. So in this case, in my calculator, I'm going to do 1.02 raised to the exponent 15. I'm going to take that answer and multiply it by 4.5, and then that will give me a final answer. Whoops. Of approximately 6.06 billion people. Okay. So the next thing I want to do is I want to try in part C, I want to predict the population for 2015. So if this equation still holds, then I want to figure out the population in 2015. So again, I take 2015 minus 1980, that was our starting value. So 2015 minus 1980 is going to equal 35. Okay, so 35 years have gone by. So in this case, my x value is going to equal 35. So if I plug this into my general equation, I've got y is equal to 4.5 times 1.02 to the exponent 35. So as I calculate it, I take 1.02 to the exponent 35, and then I want to multiply that by 4.5. Okay, so if this equation were to hold, then we'd have a population actually of approximately 9 billion people in 2015. Okay, obviously we don't have a population of 9 billion people in 2015, or rather we didn't have a population of 9 billion people, so the equation doesn't hold exactly. Okay, so now we don't have a graph, and we can't use our graph like we had before. So we want to try and figure out for part D, when will the population be 9.5 billion? Okay, so in this case, we're given a y value of 10.5. We know that the a value is 4.5. We know that the b value is 1.02. We don't know what the x value is. We don't know how much time will have gone by from 1980. So what I need to do is I'm going to plug this information into my equation. So I'm going to take 10.5 is equal to 4.5 times 1.02 to the exponent x. So now what I need to do is I need to get this 4.5, this piece, over. So I'm going to divide both sides by 4.5. And that's going to leave me, so 10.5 divided by 4.5 is going to leave me with 2.33 repeating is equal to 1.02 to the exponent x. So you'll recall in example 2 we talked about how to do logarithms. So here I've got my answer, and here I've got my base. So I'm going to do log of the answer divided by log of the base. So log of 2.33 divided by the log of 1.02. That's going to get me my x value. And so my x value, if I do log 2.3 divided by log of 1.02, is approximately 42.8. Okay, so 42.8, we can potentially round that up to just a flat out 43 years. Okay, so what that means, we haven't quite answered the question. Okay, x represents the number of years that have gone by since 1980. So if I want to finish this question, what I need to do is I need to do 43 years plus my initial 1980 time frame, okay, because all of our calculations are based on 1980. So in the year then 2022, approximately 2022 or 2023, depending on how you've rounded it, the population would be approximately 10.5 billion people.